Good morning, madam.
Good morning, Avdeshji. Good morning. Good morning, Sudipta. Good morning, all.
Morning, sir.
चलो तो बॉटल उठा के थोड़ा इधर
Good morning, DZ madam. In this web, I believe that officers from different ministries, some research institutions, and friends from our own ministry, they are joining this webinar. Some may be in the process of joining. So I welcome them all to this Envistats GIS webinar on Constitution Day today. Constitution Day, we all know, is being celebrated all over India today in order to reaffirm our commitment, our allegiance to the principal values, basic values that have been enshrined in our Constitution. And the preamble is the beginning of the Constitution, beginning chapter of the Constitution that tells what are the basic features of our Constitution. A little while earlier, we all have read this preamble led by our Honorable President of India, who administered reading of the preamble from Kavadia, Gujarat, Statue of Unity. So these are the values that are enshrined in our Constitution, and basically every day when we celebrate, it is not that we do not know those values or we do not cherish those values, but to reaffirm our commitment and remind ourselves if anything we are missing. So that is the purpose. And when we talk of Constitution, our Constitution is very comprehensive, and the day like one today is very apt that we should recall those good injunctions, good directions that Constitution provides us. And one of the field where Constitution has been very vivid in directing us as a part of fundamental duties is the fundamental duty chapter, part 4 of the Constitution, where in respect of the environment, which is so crucial to our sustenance today all over the world, day and night we are concerned about the air, about the water, about the encroaching pollution of every kind. So environment is one of the very prime concerns of our living, and our forefathers, the makers of the constitutions, our seniors were so comprehensive and apt that they could think, they could ask us, enjoin upon us that every citizen of India to protect and improve the natural environment, including forests, lakes, rivers, and wildlife, and to have compassion for living creatures. So these are the commandments that our Constitution provides us, and we in the Ministry of Statistics are alive and aware to this responsibility. And Ministry of Statistics has been compiling environment statistics in its various dimensions, and have been compiling environmental accounts, which is something novel, new, nascent discipline all over the world. Every country is in exploratory arena, how to firm up methodology, how to start valuing, how to start accounting. So our ministry has been very alive and alert to this concern, and we have been compiling in environmental statistics and environment accounts so that data and uh, perspective is available before the policymakers, before the researchers, before the government, so that they can tune their policies for the making our environment, our life sustainable, development sustainable. So, in keeping with the theme of the day, uh, we have uh, we are now having this webinar, Environment Statistics GIS webinar. Why GIS? GIS uh, data has already become all pervasive. There was a time when the data meant something relating to statistics, economics, but as the size of our activities have grown, data has become all encompassing, and then geospatial data is something very critical today in order to have better, in order to enable us to have comprehensive understanding of the situation. So we are using GIS technologies in a big way in compiling environmental accounts and environmental statistics. So that is why it was apt to include this dimension as well. So I am perhaps getting very detailed. I should not be. I was basically to welcome you all and introduce the webinar. I believe I have done that. Now I have amidst us Director General Statistics, Ministry of Statistics and Program Implementation, Dr. Shailja Shukla, who is pioneer in the field of environmental statistics, in the sense that she was the one who has been spearheading this discipline for a reasonable amount of time and given very able guidance. And under her guidance, only environmental accounts could come up in certain sectors. So I'll request her to make some opening remarks and give guidance to this webinar, and thereafter Bhanumati ji, or the Director General of the Social Statistics Division, will take over and conduct the webinar as per the agenda. So over to you, ma'am.
So good morning, all of you, and thank you, Avdesh ji, for kind of sensitizing the gathering to this topic. You have very well sensitized it, and I must also take this opportunity to thank the Social Statistics Division, Avdesh ji, Bhanumati and her team, consisting of Kajal and Sudipta and all the others who have Ruchi, who have really taken those pains, because this is a seminar session which was very much needed. And I think all of you who have worked in the environment division of the Social Statistics Division, we know that there was a landscaping also done by the environment division of the Social Statistics Division on what all has already been done in the field of environment data and accounts and what all is available. And there were so many very, very valuable studies which were found out that yes, they have already been done, but unfortunately they are not accessible because they have been done in silos. Partially they are available, the methodologies are not standard, and so as a result they have been done in some region, and the result is there with really no continuity. So probably this session, I'm sure, these 2 days, the session is for 1.5 hours, but I'm sure the discussions are going to be very, very rich. And this is a seminar which is just not for the sake of a seminar, but where all the stakeholders, research institutions, state governments, and also participants from the ministries, departments are present here. I welcome all of you to this seminar and also request you all to give your very valuable suggestions, feedback, and how we can together build the system. Having said that, very briefly, I will also like to tell the efforts of this ministry in seeing that we reach a target in terms of environmental accounting, and the journey started long back, in fact, when the ministry had started bringing out a publication on the environment statistics. So at least we knew that there is something called the environment statistics, and official data was being released, which was being used also. That publication had a lot of utility. Till time in 2011, the ministry realized the importance of the green accounts, and then the Partha Das committee was set up, and the recommendations of that, I remember at that time I was also in the National Accounts Division, and there used to be long discussions and very many meetings, and the committee came out with very good recommendations. And many a times it happens that the recommendations are just like locked in the reports only, but I will give full credit to the ministry and also to Bhanumati and her team, who kind of saw that, yeah, because she has been here for some time, and how those recommendations have to be unfolded and put to use, which was very difficult in the absence of detailed, granular, meaningful data. But having said that, the framework for development of environment statistics was done, and we started with some indicators, and we graduated, and now we are at a very, very decent level. So one publication is on the environment statistics, which MOSPI is bringing out, and the second one is on the environment accounts, and this is the third in the row which was brought out, 2018, 2019 and 2020, and we have been building on the base, that is on the 2018, where we just had the asset accounts for 4 land, forest, minerals and water, and we have been continuously trying to kind of improvise on that. Then we also have interministerial group, which contains of the ministry, which constitutes of the ministries, the line ministries. We have then, of course, the main ministry, which is the Ministry of Environment and Forests. We have members from the Jal Shakti ministry and all the related ministries. We have from petroleum and natural gas, from coal, from agriculture ministry, from renewables ministry, power, and also some of the UN organizations are also invited in those meetings to give their comments, not only just for kind of sitting there, but I have attended those meetings, and there are those very valuable suggestions from UNEP and UNES and all those organizations, and some research institutions are also there. Now, another step which this ministry took, I'll say a very bold one, was kind of going in for this National Capital Accounting and Valuation of Eco-Services project, which was Ecosystems project, which was actually, it's a EU funded project through the UNSD, and UNSD, UNES and CBD, the Convention for Biological Diversity, CBDT. These are the three in partnership with these three organizations, and there are 5 countries where this project is being done, that is Brazil, South Africa, China, Mexico and India. And in India, Karnataka, again MOSPI took the lead and did all the work, and then that project is now almost done. It has been as a pilot, it has been started in Karnataka. And the presentation of the report of that project will be sometime in January. We are going to have a forum for that, and I'm sure some of you will be attending that forum also to see what all we are getting there. And now that is probably the start of the system, because once we start getting results and what all accounts we are getting, how the system is behaving, it will be easier to replicate with some customization in the other states also. So we have already discussed about the publications of this ministry. Now when it comes to having the accounts, then obviously the methodologies are a problem. But methodologies, okay, we can still derive and think of, but data sets also become a very big problem. And I'm sure that initiatives will have to be taken, because here it is not like something you do a census or you do a survey. That can be done for some indicators, but a lot of administrative data will also have to be used, which is being, I feel, generated in some pockets and not being used. and everybody will have to share the same platform for seeing that the data is shared. So because once we have everything, then we will be seeing that yes, there is a growth in our accounts, and growth not in terms of, I'm not talking of like growth in the indicators, but the growth in the system, and where we are faring, how our resources are being used, what is the condition of our environment, and how it is affecting our economy, and how in the long term we can integrate them with the national accounts. And that can always only happen once we are kind of innovating it there, and then innovation is taking place there, and then incubation will follow. So when we are talking of the geospatial data sets, I can tell you that the Environment Division of MOSPI has been continuously in touch with the National Remote Sensing Center, and they have been using that data. They have been in our meetings. We also have representatives from the NRSC. But with the advent of technology and with the growth of technology, I feel that for the environmental accounts, the geospatial data sets will play a very, very important role in kind of fulfilling and furnishing some of our data needs. So when I see the agenda for these 2 days, I see very, very interesting sessions on global initiatives on GIS for environment accounts, compilation of soil erosion prevention services provided by the croplands using maps for visualization, and the day 2 is also very important for maps for visualization, case of water quality accounts, compilation of spatial distribution of IUC and red list, and obviously assessing the land use efficiency in cities of India. And experience sharing will be also a very important session, and I think Avdesh ji and Bhanumati ji, sufficient time should be given for this last session of the 2 days, because I'm sure that we will be having very many experienced persons who have worked in this field, and they would like to really contribute, which will be very useful in our journey towards kind of adopting, implementing and growing in this field of environmental accounts and environmental statistics. So thank you so much, all of you, and I'll be present all through these seminars. Maybe there's another meeting, so I may be just leaving for some time around 12:30. I'll again join, because I also want to kind of enrich my horizons with this with these enriching sessions. Thank you.
Thanks a lot, ma'am.
Thank you, madam. Thank you so much for your encouraging and enlightening words. Now I'll request Bhanumati ji to take the webinar to its technical dimensions, and quite a rich content for this webinar today. So Bhanumati ji, over to you.
Thank you, sir, and thank you so much, Dr. Shailaja Sharma, for helping us lay down the perspectives for this event. I really hope that all the participants have heeded to your words, and we get a lot of question answers during this webinar so that we can improve our data sets. The discussion on the Constitution actually helped me realize that it's much in line with the the fundamental principles of official statistics as well. And we as official statistics, for us, the first principle of official statistics is that to provide information for a democratic society serving the government, the economy, and the public with data about the economic, demographic, and social and environmental situation. And it is also to honor the citizens' entitlement to public information. I do hope that the National Statistical Office efforts that it has been making in bringing out these publications on environment thus satisfy some of these principles. Leo Tolstoy once famously said that one of the first conditions of happiness is that the link between man and nature shall not be broken. In this context, what comes to fore is our commitment to understand the interactions between the environment and the economy. which is being adopted by the system of environmental economic accounting that's brought out by the UNST to help our users understand that what is it that the National Statistical Office has been doing to in this direction. We would now have a short presentation on the National Statistical Office journey on the environmental accounting concept. So this presentation will be made by Ms. Kajal Jain from the National Statistical Office, and we look forward to your questions in the question answer box, and we do hope to answer some of them. Over to you, Kajal.
Good morning, everyone. I will discuss about the NSO's India's journey in natural capital accounting. Before starting, I just tell you about the two frameworks which we used for our environment statistics publication and environment accounts publication. First is Framework for Development of Environment Statistics. FGS 2013 marks out the scope of environment statistics and provide an organizing structure to guide their collection and compilation to cover the issues and aspects related to environment that are relevant for analysis, policy and decision making. FGS 2013 organizes environment statistics into 6 components. The six components are shown in the circle in the picture. These include environment condition and quality, the availability and use of environmental resource and related human activities, the use of environment as a sink for residual and related human activities, extreme events and disaster, human settlements and environmental health, and social and economic measures to protect and manage the environment. Altogether, these 6 components have indicators on the state of the environment, our dependence on it, our impact on it, its impact on us, even the negative ones, how we protect and manage it, and information come from many institutions using different concepts and classification. The next framework which we use is SIA, Framework for Environment. This is prescribed by UN and we are closely working with UNSG on this. SIA is a framework that integrates economic and environmental data to provide a more comprehensive and multi-purpose view of the interrelationship between the economy and the environment in the stocks and changes in stocks of environment assets as they bring benefits to humanity. It contains the internationally agreed standard concepts, definitions, classification, accounting rules, and tables for producing internationally comparable statistics and accounts. The SIA framework follows a similar accounting structure as that of System of National Accounts. SIA provides guidance on producing accounts for natural inputs to the economy, impacts of the economy on the environment, expenditure to mitigate impacts. Also, it supports sustainable statistical infrastructure to regularly produce relevant accounts and indicators. It also improves coherence by standardizing the concepts, classification, and methods. It reduces overlaps in data collection, that is, collect once, use many times. And it also improves relevance by linking to SNA. There are 2 perspectives of SIA, SIA Central Framework and SIA Ecosystem Accounts. SIA Central Framework starts with economy and brings in information on natural assets, flows and residual. And SIA Ecosystem Accounts starts with ecosystem and links their services to economic and other human activity. And these 2 factors together is used in our Envistats India on environment account. Together they provide the foundation for measuring the relationship between the environment and economy and other aspects. Now we'll talk about some benefits from ecosystem. The figure shows that like we inhale oxygen and exhale carbon dioxide, similarly the forest, which are also the lungs of the world, they inhale carbon dioxide and exhale oxygen. Trees absorb greenhouse gases. Trees boost our mental health while raising our physical health. They also clean the air so we can breathe more easily. Trees gives a home to the wildlife we live. We think that trees help in the formation of raindrops. Amazon and Congo forests, they are actually breathing water vapor into the atmosphere, whereas we think it's the water vapors are from rainfall. Now I'll talk about the two publications which we released. First is Envistats India Volume 1, which is on environment statistics. This publication is based on FDS 2013. The set of indicators prescribed were divided into 3 tiers. Tier 1, which corresponds to the core set of environment statistics, which are of high priority and relevance to most countries and have a sound methodological foundation. Tier 2 includes environment statistics which are of priority and relevance to most countries, but require greater investment of time, resource, or methodological development. In the Tier 3, indicators include environment statistics which are either of lower priority or require significant methodological development. In 2018, the first publication was released. We started with around 134 indicators in this publication, and which were increased by more than 80 indicators in our 2020 publication. Now we have released our Envistats India Volume 1 Environment Statistics with 217 indicators. The second publication which we released is Envistats India Volume 2, which is on environment accounts. 2018 and 2019 issues covered the topics asset accounts, that is combination of environment and ecosystem accounts, and asset accounts for land, water and mineral was covered. It also covered forest account, which covers forest cover, growing stock of timber and carbon. In the next publication, that is which was released in 2019, we covered topics like soil nutrition indices for various macro and micronutrients, water quality accounts of river water in select river basins, water quality accounts of groundwater in some states of India, water quality indices of seawater across certain coastal monitoring system. We also covered district-wise values of ecosystem service provided by the land in the provisioning of crops, and state-wise values of nature-based tourism services. In 2020 issue, we covered topic on land, croplands, forests, wetlands, biodiversity, and SIA monitoring for sustainability. So, till date, we released 3 publications each on environment statistics and on environment accounts. Now, we will see few examples where GIS is used in compiling environment accounts. The first example which we consider is crop provisioning services. As you all know, agriculture is a key sector of the economy. The administrative data used are cost of cultivation studies conducted by Ministry of Agriculture and Farmers and Welfare, and also the data on area production of different crops released by the same ministry. The ecosystem services provided by cropland in the provisioning of crops are the total and combined result of processes taking place in cropland that support crop production, such as infiltration of water, the water holding capacities of the soil, etc. SIA prescribes the use of resource length method, which provides a gross measure of the value of this cropland ecosystem service to crop production. In this, the district-wide estimate of the value of cropland ecosystem service per unit of net area zone and per unit of geographic area of districts were presented. The estimate has been compiled using appropriate method prescribed by SIA. The details would be discussed today in the upcoming session. The second example which are covered is status of groundwater. The administrative data source departments are Central Groundwater Board for groundwater and Central Water Commission for surface water. Water quality accounts are one of the most effective ways to describe the quality of water and to assist in the formulation of appropriate policies by various environmental agencies. These accounts not only allow for comparability across water bodies or across time periods, but can also be used in assessment of impacts of pollution and can help evaluate the policies aimed at decreasing pollution or improving the state of water bodies. The groundwater quality accounts for the state of Punjab has been shown in the figure, which has been compiled on the basis of the data available on groundwater quality parameter provided by the Central Groundwater Board for 291 sites across 119 blocks in 22 districts of the state. Similar analysis was also done for the state of Haryana. Case of water quality would be discussed in detail in tomorrow's session. The third where the GIS application is used is extent of nature-based tourism. Nature-based tourism is one of the classical examples of the interaction between environment and economy, where the economic activity of tourism is affected by the status of environment and at the same time also affects the state of environment. The administrative data, survey data and big data are used to compile the extent of nature-based tourism. Administrative data was from India State Tourism Report of Ministry of Tourism. Survey data was NSO's data, and big data which was used from Flickr. The annual publication India Tourism Statistics published by Ministry of Tourism gives the annual number of domestic and foreign travel visits by states of destination. State level detailed information on tourism is available in the State Tourism Survey, which includes information on important tourist destinations and various characteristics of the tourist. The National Sample Survey Office has conducted two focused household surveys on domestic tourism, one during July 2008 to June 2009 and the other in July 2014 to June 2015. The survey provides a detailed insight into several characteristics of domestic tourists. Duration of stay, origin, destination, etc. were generated. And these two, on the basis of these two, the extent of nature-based tourism was calculated, were estimated. And the estimate derived for the year 2008-9 and 14-15 for nature-based tourism. The 2014-15 map is shown on the left-hand side, which was validated using the Flickr, which is on the right side, Flickr photo users days. And we can see that both the maps are similar. Values derived in 2014-15 as a product of average expenditure incurred by per person, number of tourists having the specified purpose, and as I told, both it is validated using Invest model by Flickr user photo user days. Now the third example which we'll consider is land use efficiency. Land use efficiency is defined as the average annual rate of change of built-up area per capita. The map shows positive, negative and zero values of land use efficiency. Positive value indicate a faster increment of population than built-up increment. Values around zero indicate stable zones with a linear increment of built-up surface and population. This is an example of Delhi state. In order to help assess the status of million-plus cities in India with respect of SDG indicator 11.3.1, experimental estimates of these cities were compiled using the land use efficiency tool developed for this purpose by Joint Research Centre of the European Union. Here the global data set of spatial data of gridded data set is used. Combination of administrative data and remote sensing data is used together. Next example we'll consider is soil erosion prevention services. Here the global and local GIS datasets have been used to quantify the amount of soil loss in the croplands. An attempt has been made to assess the soil erosion prevention services provided provided by the croplands ecosystem in India. The figure shows a spatial and temporal distribution of soil erosion prevention services provided by croplands in India. In today's session, there is a complete session on this soil erosion prevention services. Red list species. The IUCN Red List of Threatened Species contain global assessment for over 120,000 species. The IUCN spatial dataset can be used to evaluate the species richness of the red list species of any defined region or area. Species richness represents a measure of variety of species based simply on account of the number of species in a particular sample and is generally expressed as the number of species per unit area. The IUCN Data Repository has spatial data sets on mammal, amphibians, birds, reptiles, fishes, plants and other groups. More than 80% of the total red list species have spatial data. The identification of threatened species by Botanical Survey of India and the Zoological Survey of India for plants and animals respectively, which are on the verge of extinction or likely to become extinct in near future, are notified legally as threatened species under Section 38 of the Biological Diversity Act 2002. The detailed discussion will be there on tomorrow's session. Now, what NSSO is planning next? We are conducting a forum, NKX India Forum 2021, on January 14, 2021, January 21, 2021 and January 28. Here in these 3 days, in the opening session which will be on January 14, international organizations will talk about the latest development and their role in natural capital accounts. There is also a Twitter poster session throughout the 3 days. On day 2, we will discuss on policy demand for natural capital accounts and role of thematic accounts in policy. And day 3 will be on achievements in India. Many studies have been conducted in India and these will be showcased by official agencies like FSI, NRSC on their studies in environment accounting. So please join this forum also. Thank you very much. Over to you, ma'am.
Thank you, Kajal, for the discussion, and I do hope that we've got you excited to ask us queries on what is it that we would like to improve upon and what do we need to improve upon in terms of methods, in terms of data sources. Again, referring to the fundamental principles of official statistics, Principle 3 of the principles say that the official statisticians are bound to present information according to scientific standards on the sources, methods and procedures of the statistics. We do hope to make interventions in this regard and to improve upon the set of environmental accounts that we've attempted so far. Under the UNST, we've been lucky to be part of the EU-funded project on natural capital accounting and evaluation of ecosystem services. This project has opened up the horizon, if I may say so, for the National Statistical Office to venture into different data sources, to pilot different methodologies, and to attempt compilation of few accounts at the national level. But then, yes, as all of you who have joined us today may understand that environment is just like onions. There are so many layers to it that it's impossible for us to get this done in a short time frame. But every journey of 1,000,000 miles starts with just one step. So we do hope that we started by taking the step in the right direction. Under this EU-funded project, we had the opportunity to get technical guidance from the Victoria University of Wellington, basically by Dr. Bethana Jackson from the Victoria University. who has helped us attempt the use of GIS for the environmental accounts. Not that the expertise is lacking in the country, but then because it was just a part of the project, we did attempt using the global data sets, which also helped us in some ways not reinvent the wheel. We started using the published methods, the international methods, and the well-validated data sources. So in our next presentation, we have Dr. Bethana Jackson, who will be talking to you about how global data sets are being used for the purpose of environmental accounts in India and elsewhere. So Dr. Bethana, can I please hand over the mic to you to please present your presentation. Thank you.
Please do. I think you are going to bring the PowerPoint up on the slides.
Yes, it is.
Thank you. Perfect. Greetings everybody, or in our country's language, Tēnā koutou koutou. Yes, so we have been working in the NCAPES project. So this project funded by the EU and with support from the United Nations Statistics Division and environmental program to look at supporting how we trial the use of GIS and biophysical modelling in the environmental accounts, and we have been working very closely with NSO. And this is a presentation not just with myself, but also with our postdoctoral fellow, Rubienka Benavides, who is going to take over from me a few slides in. I just want to make a couple of comments just based on what we've already heard. I thought it was just amazing the points that Shalija made in terms of how big data, GIS data, geospatial data is just coming on. We are making enormous innovations, and this is a really developing field. And I think what India is doing with a couple of other countries is really innovative, and we are really excited to be kind of like part of working with that. And also in terms of the comment that Banamati made in terms of 1 million steps and we're taking one, I think our presentation is going to be a few steps back from what Ruchi has presented, because we have been part of collaborating with NSO and others in terms of some of the first steps, but then India has been making major steps beyond that, which will come out in the later presentations. So next, please. So we're going to just give a little bit of an overview of the environmental accounts, although again, Ruchi did a really nice overview of that. I'll present a slightly different perspective, but I'll not belabor it too much given the nice account she's already given. A little bit of an overview of the global GIS data, and again completely get the point, and we believe in the point that it's the innovations that are happening in this in terms of geospatial data, satellite data. It's just a changing field, and it's quite exciting. But also the importance of national and local data and how we can use those to support the accounts. And we'll talk a little bit about applications using global, national, and local data, but just be aware that what we've been mostly doing is focused on using the global data in collaboration with NSO and other partners, and then NSO and other partners in India have been taking that on to get much better kind of estimates using the better national and local data. Next, please. So in terms of environmental accounting, so our association with the National Statistics Office has very much come about because we have been part of the system of environmental economic accounting, which has been very much, put out by the United Nations with a whole lot of collaboration and talk in terms of how we do this. And it is the accepted international standard for environmental economic accounting, and as statisticians, they're looking for agreed sets of standard concept definitions. However, once you start to go into the economy, but not just the economy, but also the ecology and people, things aren't that easy to get an agreed set of definitions on. So there's been a lot of talk about that. But basically, we're trying to provide a statistical standard that provides information on extraction, use, and stock of our resources, so timber, food, etc., but also really changes in environmental characteristics and stocks over different years. And as time has gone on, the importance of this to actually help feed scenarios and future policy has become more and more important. Our particular approach, working again with NSO and a couple of other partners and with the NCAVES project, this EU-funded project, is very much focused on the ecosystem accounting part of the system of environmental economic accounting, the SEA. And that's very much a spatial approach, and we are trying to respect biotic and abiotic elements of ecosystems. And there's a tension in terms of intrinsic and an instrumental worth. So the instrumental, perhaps the economic, the people-focused, and the intrinsic true valuation or acknowledgement of the worth and importance of those protections. And just in the very opening presentation, I thought it was just amazing that India's actually got embodied in its policy to look after living any living creatures. I thought that was lovely. Next. I won't belabor this too much because there's lots of other stuff to cover, but thematic areas of the SEA, and again divisions end up being a bit arbitrary. Agriculture, forestry and fisheries, very much provision, but also looking at trying to keep the condition and their intrinsic integrity. Air emissions accounts, energy, activity, and as I've already said, ecosystem accounts are very spatial, and that's where we're mostly contributing. Land accounts and material flow accounts. Next. And again, this has already been referred to in the previous presentations, but this is a changing field and an exciting field, and India is doing a lot in leading in it. And we're really trying to link some of the indicators, but also start to kind of like bring into account the Sustainable Development Goals. And I think, later in the presentations in this kind of like overall seminar, you'll start to see how the environmental accounting is not just supporting the SEA, but it's bringing in accounting on how we're doing in terms of the Sustainable Development Goals. So lots of interesting things kind of like happening in this space with these various initiatives kind of coming together. So yeah, holistic kind of perspectives, trying to really bring all of the innovations together. Next. Okay, this is my last slide before I hand over to Bianca. So in terms of global GIS data, there's really exciting innovations, and a lot of that is in terms of remotely sensed data. So there's Landsat, the Sentinel Modus, and the Sentinel in particular, in some things can actually resolve things to 15 to 20 meters by meter pixels, which is quite exciting if you're trying to look at really like locally kind of achieved outcomes. Again, topography, digital elevation models, and India has its own kind of space and satellite information, which actually kind of like adds to this. Land use and land cover, so probably for the purpose of environmental statistics, the most important thing is the European Space Agency CCI land cover, because that's updated annually. So you can't really do accounting if you just have one timestamp. But some of the products around soils, again, some examples. These are not so much from satellite data, they're more countries kind of coming together to combine data and classifications, climate and hydrology, and again, some of that also coming out of some of the meteorological and climatological modeling. And I'm just having a technological issue in terms of Teams putting some stuff so I can't see the last points. But yeah, one of the big points that comes out is that when we're talking about environment, thank you whoever did that, environmental accounting, the most valuable data sets, both globally, nationally, regionally, locally, are those with multiple time steps, so we can actually kind of like look at opening and closing date. And there are biophysical modelling guidelines about to be released for consultation truly within days, before the end of this month. They will be finalised in 2021 when the SEA ecosystem accounting is finalised, or the guidelines for 2021 are finalised, and this contains quite a lot of guidance on what globally we think the most relevant data sets for accounting might be. Within India, again, I just think in terms of data sets that get updated at regular periods rather than static ones. And next, and I'm going to hand over to Bianca, our postdoctoral research fellow.
Yes, good afternoon, everybody, or good morning, or good evening if you're from New Zealand. So I am Bianca, and I've been working with Beth about these things. I've been working with global data quite a bit, and I'm going to be picking up in this presentation with things to consider when using global data. So the first thing to really think about is whether or not the global data is suitable for your application. There have been many times when I found a global data set and thought, awesome, I can use this for my work. And then I look into it and think, it's not exactly what I want. The second thing you should consider is your availability over your study area. Now, since most global data is available globally, usually this is not a problem, but you may want to be able to look at whether or not the global data is only limited to certain regions, to certain land cover types, etc. The next thing you're going to want to look at is the spatial resolution, or sort of the pixel size of that data set if it's a raster. So if you're doing things at very large scales, say national, regional, or state, that might be some coarse resolutions might be suitable. Let's say I think Landsat's, the DEMs from SRTM are about 30 meters by 30 meters. Some global data sets are 1 kilometer by 1 kilometer, which is appropriate at national scales. But if you're doing very smaller scale things, like say at catchment or at field or subcatchment scale, your finer spatial resolution would be a lot better. The next thing to consider is the temporal resolution of that global data set. So as Beth mentioned in the previous slide, for biophysical work that we do, we prefer when things are most usefully at the annual scale. So if you want to look at something at annual scales, make sure your data is at that scale. Or if some accounts are very important at seasonal scales, such as water or soil erosion or vegetation. The next thing to look at is the classification system that is being used, and I'll bring this up in later slides of my presentation, how we found how global data sets sometimes have quite coarse or broad classification systems that don't necessarily capture local conditions. Basically, every data set has its own assumptions, caveats, quality flags, etc. And when you first see a data set, it's very important to read the technical documentation and the metadata to get to know more about it before you actually start using it, if that makes sense. Next, please. So even though we touched on global data and how awesome it is, I also want to stress the importance of national and local data. National and local data is really valuable, but it's not always obtainable. In our work with Banamani and her team, I'm really excited to see that there's lots of valuable national data in India, which can improve environmental accounting as buy-in is achieved. So why is it important? Because national and local data augments global data because it better represents country-specific or smaller site conditions. Usually, national and local data has more detail on specific ecosystem types, specific soils, vegetation. For my work with soil erosion, I'm finding that more national and local data have better land cover representation. Basically, these kinds of data sets have higher accuracy, generally, and higher resolution that may identify areas, details, changes, or transitions that some global data sets might miss. Next, please. So sort of backtracking to a little bit of introduction of who we are. So we're the LUCI team, that is the Land Use Capability Indicator Model. And here's how we started. And I must confess that I wasn't around when the LUCI team was first formed, but I've been working with it for the last 5 years. And any mistakes I make about Lucy, I'm sure Beth will jump in and correct me about.
I will, and punish her terribly afterwards.
Thank you. So what is Lucy? Basically, it's a land management decision support tool or a support framework. The required inputs for the Lucy model, so the main Lucy model, are a DEM, so a digital elevation model for topography, land cover, and soil. But there's also optional inputs, like I said, locally sourced data, which has more detail and more accuracy, such as climate, water, geology, and management data, among others. The Lucy model is spatially explicit, so it runs from subfield to farm to national scale, and you'll see some of our results later on. The Lucy model models the spatial distribution of ecosystem services, as well as opportunities, trade-offs, and synergies, essentially pointing out to management where you might have hotspots or areas where you could prioritize management interventions. Next, please. So a spin-off of the Lucy model is this model, or this toolbox, called the Lucy for SIA version 1 toolbox. This one doesn't have all of the tools from the main Lucy toolbox, but we brought some over that we found useful to our SIA work. So this toolbox is working in ArcMap. It's freely accessible and open source to help support SIA work. And sort of our guiding principle for this toolbox was that it should be able to support freely available and global data sets, or have the option for the user to supply their own data if it's available. And that's a link to the GitHub where you can find this toolbox. It's accessible right now. Go ahead and use it to your heart's content. Let us know how you find it. We'd love to hear some feedback about it. And at the moment, only the Russell tool from the main Lucy toolbox was brought over. But as development continues, we're hoping to bring in more ecosystem services that work with global data. Next, please. I won't touch too much about this because in the pre-presentation by Kajal, they gave a great overview of what's going on with the work with NSO, and I believe there are upcoming presentations covering all these in detail. So things like land cover change accounts, ecosystem condition, soil erosion. We did a bit of carbon work, but I'm not sure if that's going to be talked about. Species richness and diversity, and urban areas. Next, please. Yes, soil erosion, what I've been working on for the past few years. So just as a proof of concept, I use global data sets. So the SRTM-DEM, rainfall erosivity from Panagos et al., the harmonized world soils dataset, and land cover from the ESA CCI, just to give a preliminary run of soil loss over India, mainland India, that was applied over using the revised universal soil loss equation. But actually what we found when looking at these and after getting feedback from our amazing colleagues over there is that these global datasets were not exactly able to account for areas of bare rock or permanent snow and ice or where there were glaciers. So maybe things at high elevation might need more tweaking and refining. And speaking of refining, there are some local data sets of land cover and land use from NRSC, which I believe our colleagues will be talking about and how they've used it in subsequent presentations. But the point of this slide was just to show that it is possible with global data, but also with a caveat of global data sets may not be able to account for things that are very detailed or very local. Next, please. Another proof of concept. Here's sort of the same idea, but this time it's over Brazil, which is another one of the countries that we have had connections to. This one is using global data as well, and then running it over the entire country. And this is an example of how you present soil erosion. On the left, you have this map at sort of pixel level, where you have the green areas being lower soil erosion and yellow, red areas being higher soil erosion. Now, well, I think that's personally really interesting because to me, I get to see sort of where the big patterns of high soil erosion are. Something like on the right, so something distributed at state level might be more important for management or for administrative agencies. And I believe you saw a lot of these district boundaries aggregation sort of maps in the previous presentation. So this is just sort of how we're trying to figure out what's the best way to present soil loss. and getting more feedback from people on what they need to see from soil loss maps and what kind of scales they use is really important to us. All right, next please. Yes, I think I might toss this back to Beth because this was Lucy work that happened before I was part of the team.
Sure. Well, it's part of the SEA for Lucy, or the Lucy for SEA toolbox. And I think we're kind of running a bit out of time, so I'll just mention this briefly. But this is we're actually aggregating over here by 1 kilometer by 1 kilometer grids and looking at biodiversity indices as a surrogate for condition. So on the left, we've got mean patch size in terms of habitats. And then on the right, we've got a slightly more mathematical kind of indication of diversity based on the number of habitats. It is, of course, very subject to the quality of your data and how many kind of like the detail on the habitats you actually include. So yeah, next.
And I'll pick it up from here. So another part of the work that we did was around species and diversity, and I believe it's already been mentioned that we used the IUCN Red List species dataset just as a proof of concept. We produced some sample output for Karnataka and produced a workflow in collaboration with our NSO colleagues that I believe someone will be presenting on later on. So the IUCN Red List species dataset is really interesting because it's a global, essentially a stacked dataset of many layers of shapefiles, and it's a prime example of big data. So it's interesting to try and separate out those layers and be able to produce something like this, a map that shows essentially darker green, showing that more red list species occur in those areas. And what we found working with our colleagues is interesting differences in sort of the kind of GIS programs that we use and how it handles this really big data set.
Yeah, there are very big data issues, particularly around this data set. And I just want to kind of like point out that this is, again, one of the points where we've taken some of the steps towards the 1 million steps, but some of the upcoming presentations are going to take this further, and Richie has already alluded to that. So yeah, this is a lot of the preliminary work that we were kind of like doing in collaboration with NSO and also with the UN, and they've taken it on further, and we'll hear about that in the next presentation.
And this one revolved around urban green spaces, urban areas, and land consumption. So the Sustainable Development Goals. So for this animation you're seeing, this was produced using a combination of global data from the ESA CCI and national data. So the NDVI from the Ruvan portal. And it's just a little sort of preliminary application to Delhi and showing the 2015 animation. And I believe this is being applied at bigger scales. And so next please, and I'll pass it back to you.
Beth and Bianca, I need to really, I know it's harsh, but we need to wrap this off, if you don't mind. For all our users, we'll share the remaining slides. If there are any parting thoughts, Beth or Bianca, please. Before we go on to the next presentation.
That's all good. Thanks, Panamati.
Thanks a lot, and it was really wonderful to listen to both Beth and Bianca talking about the challenges of using the global data sets. From taking a lot from these two people and basically the UNSC NCASE project, the National Statistical Office has tried to improve the efficiency and accuracy of all of these accounts by borrowing some of the global data sets and the internationally prescribed methods. We would now be listening to Dr. Ruchi Mishra, who will be talking about the prevention, soil erosion prevention services that the National Statistical Office has compiled. The results of this study are available in our publication Envistats India 2020. I really would appreciate if you could have a look at the publication. There are a lot of data sets which are available in that particular publication. So over to you, Ruchi.
Good afternoon, everyone. Welcome to the Envistats India GIS webinar. In this session, we'll see how the spatial data sets have been used to quantify the soil loss in croplands in India, and also we have attempted to assess the soil regulation services provided by the croplands. Cropland is defined as the land area under temporary crops such as cereals, temporary meadows, land under market or kitchen gardens, land temporary fallow, and the land under permanent crops. Croplands are important ecosystems as they provide several ecosystem services like food production, air regulation, soil and water conservation, environmental decontamination, and so many other services. Croplands are also critical for helping the world tackle climate change as they have carbon mitigation potential. India has around 156 million hectares of cropland. So the figures on the screen shows the spatial distribution of croplands in India over the years. The graph shows that India has major area under croplands. The extent and condition, so it is an important ecosystem, and the extent and condition accounts for the croplands have been compiled and published in our publication Envistats India Volume 2. Now coming to the problem of soil erosion. Erosion occurs when soil is left exposed to raindrop and wind energy. The loss of soil due to erosion reduces the productivity of all ecosystems, as all ecosystems are strongly linked. It has been found in many studies that soil erosion is the major problem for agricultural land as it removes the nutrient that is essential for the growth of plants and increases sedimentation of river channel and reservoirs. The croplands eroded are abundant and also the productivity of the remaining land reduces. This leads to the creation of new cropland out of forest and pasture land to meet the present demand, and it affects the other ecosystems. So, soil erosion reduces the general productivity of terrestrial ecosystems. It increases water runoff, thereby reduces the water infiltration and water storage capacity of the soil. Given these negative effect of soil erosion, it is important to assess the amount of soil loss in the croplands area. In this background, an attempt has been made to use GIS data to quantify soil loss in the croplands and assess the soil regulation services provided by the croplands. So, although the soil erosion is affected by several factors, but there are three main factors that affect erosion. The first one is the soil structure. Soils with medium to fine texture, low level of organic matter content, and weak structural development are most easily eroded. These soils have low water infiltration rate and are more prone to soil erosion. The second factor is the status of vegetative cover. Land areas covered by plant biomass are more resistant to wind and water soil erosion. The topsoil is held together by the biomass, and the raindrop and wind energy are dissipated by the biomass layer. The third factor is the land topography. The topography of a given landscape, its slope, also influences the land's susceptibility to soil erosion. Now I will discuss about the soil erosion prevention services. The soil erosion prevention service provided by the croplands is an important ecosystem service as it mitigates the negative impacts of soil erosion. To assess the soil erosion prevention services provided by the croplands, a counterfactual analysis is done. At first, the erosion that would occur when vegetation is absent, or in other words, when the land is bare soil, is evaluated. Now this erosion is termed as the potential soil loss. The next step is to estimate the soil loss in presence of ecosystem, that is, in our case, in presence of croplands. The actual ecosystem service can then be determined by the difference between potential soil erosion and the impact mitigated by the croplands ecosystem. So, as already discussed, owing to the impacts of soil erosion on decline in productivity of arable and non-arable lands, estimation of soil erosion is of utmost importance. Use of soil erosion model is useful step in identifying the critical areas vulnerable to soil erosion. One such empirical soil loss model is a revised universal soil loss equation, that is Russell. The equation is given on the screen. The Russell is designed to predict the long-term annual average of soil loss and has been widely used and applied around the world due to its relative simplicity and low data requirements as compared to the more complex models. We have also used Russell here, and Russell uses information on land topography, soil data, rainfall data, and land use and land cover information to determine the annual average soil loss. To implement Russell, several GIS datasets are used as input to generate factors, that is R, K, LS, C, and P, and to estimate the annual. Then these factors are multiplied together in GIS environment, and we get the estimate of annual soil loss. The DEM is used to generate LS factor, which uses the information on slope gradient and slope length, and the LS factor shows the topographic erosivity. The soil data are used to generate K factor, which represent the soil erodibility. The higher K factor denotes the soil's higher susceptibility to erosion. The rainfall data are used to generate R factor. This factor shows the influence of rainfall on soil erosion. The land use and land cover datasets are used to determine to parameterize the C factor. The C factor ranges between 0 to 1, and the bare areas which are more prone to soil erosion receives values closer to 1. The land management information is used to parameterize the P factor. Now coming to the data processing and factor generation for soil erosion for croplands in India, we have used several local and global datasets for this purpose. The table shows the summary of the data sources used in Russell to quantify soil loss. In this study, DEM from NASA are used to generate LS factor. The harmonized world soil database from FAO has been used for the parameterization of K factor. The rainfall erosivity database is used for R factor. For the C factor parameterization, the land use land cover dataset from National Remote Sensing Center have been taken, and based on the previous studies in India that has shown agricultural land, C factor has been fixed as 0.23. Now the table shows the experimental estimates of soil erosion prevention services provided by the croplands that have been compiled for the 3 years 2005-06, 11-12 and 15-16. The values are observed to be high for hilly states, which may be attributed to steep slope. Now the graph shows the amount of soil loss that have been prevented by the croplands. The darker shade shows the higher amount of soil loss prevented. The zero indicates the non-cropland areas. Now coming to the way forward, the estimates of soil erosion prevention services presented here are preliminary. Further improvements in the parameterization need to be made with the expert knowledge and local datasets. And this exercise focused over mainland India, excluding the island due to the coarseness of resolution and difference in the extent of global dataset for such a small area. To conclude, in this session we discussed how the global and local GIS datasets can be used to estimate the soil erosion. Now this brings us to the end of the presentation. I will finish up by saying thank you for joining us and thank you for your kind attention and interest. Over to you, ma'am.
Thank you so much, Ruchi, for the wonderful presentation. And let me first tell our users that this is only the first set of estimates. These are experimental in nature, in the sense that we are working with the Soil and Land Use Survey of India and the National Remote Sensing Center to improve these estimates by localizing these global data sets, the factors used there, and as Ruchi pointed out in her last slide on way forward, we are working on having improved parameters that can help us inform better. I did see a mention about soil erosion disservices. Yes, that of course, I'll be taking in all the questions tomorrow during the question answer session. I do hope that this is an incentive for you to come back to us to attend the webinar tomorrow. But before we wrap up for the day, today we have a short presentation on how we used GIS not just as a model input, but also to inform better, because maps are more informative than the tables, as we found out the hard way. Dr. Suvita Ghosh from our office will be presenting this presentation on the use of GIS maps for showcasing the crop provisioning services. Over to you, Suvita.
Thank you, ma'am. Very good afternoon to all of you. I, on behalf of Ministry of Statistics and Program Implementation, welcome you all to the Envistats India GIS webinar during 26th and 27th of November 2020 to celebrate the GIS Day. As you all may be aware, the National Statistics Office, Ministry of Statistics Program Implementation, brings out a regular annual publication of Envistats India Volume 1 and Volume 2 in the month of March and February respectively. While Volume 1 gives information about statistics related to environment, Volume 2 gives details about the environment accounts. We have made use of the Geographic Information System in compiling the environment accounts. In our earlier presentation, we have seen the compilation method of the soil erosion prevention services provided by the cropland. Today in this webinar, I take this opportunity to showcase our use of the GIS maps in the environmental accounts, particularly for the crop provisioning services. Coming to the introduction, agriculture is the key sector for the India's economy. But does that mean that agriculture is necessary only for food? Of course, no. Agriculture is vital not only just for food and non-food production, but also to rural development and poverty alleviation. It is the prime source of livelihood for 40% of the total household in the country. It has helped in reducing poverty by providing employment and food security. If we talk about the geography of the country, India can boast of having an extremely divergent geography. The cropland area of India spans to about 156 million hectares. As a result of the diverse pattern in season, topography, geography, culture, and socio-economic conditions of the country, the agricultural ecosystems in India also shows tremendous variations. India has got 20 different agroecological regions and 60 agroecological sub-regions. Consequently, there are a wide variety of agricultural practices that are currently being followed in the country, such as subsistence farming, plantations, rotation farming, annual crop monocultures, temperate perennial orchards, shifting cultivation systems, smallholder mixed cropping systems, paddy rice systems, and terrace cultivation. Also, India has 3 distinct agricultural cropping seasons such as Kharif, Rabi, and Zaid. Now, before discussing about the provisioning of crops, let us know what is ecosystem services. Ecosystem services are the contributions of the ecosystems to the benefits that are used in the economy and other human activity. There are 3 categories of ecosystem services: provisioning services, regulatory and maintenance services, and cultural services. In the current presentation, we'll be focusing only on the provisioning services for the cropland ecosystems. The cropland ecosystem provisioning services is the contribution of the ecosystems to crop production, that is, the total and the combined result of the processes taking place in cropland that support crop production. This includes infiltration of water, the water holding capacity of the soil, the absorption of plant nutrients by soil particles, and the resupply of these particles to plants. Apart from these, the cropland also influences regulating services that provide benefits external to the farm, regulating water and air quality, storing soil carbon and supporting biodiversity, pest regulation, and maintenance of soil quality and biodiversity. Next. Now, coming to valuation, why do we need valuation? It is important to evaluate the provisioning services so as to understand its importance. Unless we put a value to these benefits, we tend to ignore their services. Also, putting a value will help for framing policies and for improving incentives for better management of ecosystems and natural resources. In addition to it, when we put a value to the services, links between the ecosystems and the economy can be made. System of Environment Economic Accounting, Ecosystems Accounting, developed by the United Nations, which forms our basis for compilation of the environmental accounts, prescribes the use of resource rent method for estimating the value of this ecosystem service. The measurement of the resource rent provides a gross measure of the value of the cropland ecosystem service to crop production. Valuation of the resource rent helps to compare agricultural land with different environmental assets using a common numerator. Resource rent in monetary terms may also provide useful information for assessing future streams of income from agricultural land for household. In the Envistats Volume 2 for the year 2019, district-wise estimates of the value of the cropland ecosystem service per unit of net area sown and per unit of geographic area of the district has been presented for 3 years, 2005-6, 2011-12 and 2014-15. We have used the appropriation method for valuation. It is the method wherein the actual payments made to owners of environmental assets in terms of rental value of owned land or rent paid for leased in land are taken into account. The sources of data for compilation is primarily from Ministry of Agriculture and Farmers Welfare. We have three major data sources. Cost of cultivation studies, which is an important mechanism for data generation on cost structure of crops. Information on area production and yield of major crops, which can be obtained from the publication of agricultural statistics at a glance by Directorate of Economics and Statistics by the Ministry of Agriculture and Farmers Welfare. This is one of the trusted data sources of information to gauge the performance of the agriculture and elite sectors of India. And the third data source is the land use statistics, which is collected by Directorate of Economics and Statistics and Ministry of Agriculture and Farmers Welfare on the ninefold classification of land, irrigation area, source-wise and crop-wise, and total area under crops from all states and union territories of the country. Now coming to the computation method, the first step is we calculate the rent for CCS states and CCS crops. The total rent per hectare is equal to the sum of rent paid for leased in land or rental value of owned land obtained from CCS. We have in the analyzed data sets, we have 19 CCS states and 24 CCS crops. Then the rent per hectare is imputed for all the states and all crops that are available in CCS. For states where CCS is not available for some crops, missing rent is imputed crop-wise using rent from the neighboring state. For states where CCS is not available for some crops and CCS of those crops is also not available in the neighboring states, rent is imputed with minimum rent of that state itself. Then impute for non-CCS states and CCS crops. For non-CCS states, rent for the CCS crops has been imputed from the nearest CCS neighbor. And impute for non-CCS crops. For crops where CCS is not available for any state, rent has been imputed with the minimum rent of that state itself. Since the crop-wise information is available for gross area sown and not net area sown, an adjustment factor has been derived from the land use statistics, which is nothing but net area sown divided by gross area sown. So using the method, we calculate the resource rent for a state for a crop for a year, which is equal to rent per hectare of the state into area under the crop for that state into the adjustment factor. Resource rent for a state per unit quantity of crop for a year is equal to the resource rent for the state for a crop divided by the production of that state. Resource rent for district for a crop for a year is equal to resource rent for a state for a crop per ton into production of that district. Total resource rent for a district for a year is equal to the total of all crops as given in area production and yield. Now, resource rent in the Envistats India publication 2019 has been shown for the years 2005-6, 11-12 and 14-15 in terms of resource rent per unit of geographic area of the district to take into account the productivity difference between the districts. Although we had data available for all the years by the Ministry of Agriculture and Farmers Welfare, we have considered taking 3 years information so as to match with the National Remote Sensing LULC data. Now, we see here two maps. We compare the LULC map for cropland with that of the Cropland Ecosystem Services map. In the LULC map for cropland, the green areas depict the cropland area while the white ones are the areas other than the cropland. And the ecosystem services map shows a more granular level information segregating the country into different classes according to the ecosystem services provided, such as very low, low, medium, high, and very high. The dark green areas are the areas providing very high ecosystem services. From the map, we can see that the Indo-Gangetic Plain shows the prevalence of the cropland as well as the cropland ecosystem services, showing almost a one-to-one correlation between the two. But things are not similar throughout. For states like Kerala, we see that although there are no cropland in the area, but the crop provisioning services are more. It is because there are presence of other plantation crops which are providing the provisioning services. For example, Kerala has the presence of rubber plantation which are providing the ecosystem services but do not fall under the purview of the croplands. These are not reflected in the cropland maps. Next. Similarly, this is for the year 2011-12. We see for the state of Gujarat, the LULC map for the cropland shows the prevalence of the cropland area, while the ecosystem service map shows that there are different levels or grades of provisioning services. This implies that the value for money is not as expected. The monetary returns are not much. So we might want to frame policies which will help to improve the health of the ecosystems so that good quality services can be derived out of them. Hence, we see that use of the GIS maps help in better understanding the actual scenario. Next. This table shows the state-wise resource rent distribution for the year 11-12. And the same, this is depicted in tabular form. The table gives resource rent categorized into 5 classes: very low, low, medium, high, and very high. This table is no doubt very informative as they form the basis for the compilation of the maps. But when we talk about the visual representation, maps are always at an advantageous position. Next. Now, talking about the advantages of the maps, there are plenty of advantages that the maps have. The information provided in the maps is more appealing and gets registered easily. We can play with different color codes, having different parameters and having different interpretations. Detailed information provides a very useful tool for the policy making. We can actually pinpoint the areas for the policy makers where exactly they need to intervene. Tabular information often lacks granularity, which is captured by the maps. The tabular information is often dull and dry. Maps give them a view full of life. GIS data are more transparent. We can actually see the performance of the areas, district, and sometimes even below. And this improves allocation of resources and planning. Depending on the precise location, the funding may be allocated to the areas requiring attention. Then next, way forward. Now, if we had the latitudes and the longitudes of the farms and the corresponding crops, further analysis could be made. A further detailed exercise could have been carried out, which would focus on the farmlands better. Currently, we have just started with the process of using GIS maps in our analysis. We are striving hard to incorporate more and more GIS maps in our analysis and improve our visual presentation. Thank you for your attention. Over to you, ma'am.
Thanks a lot, Savita, for the wonderful presentation. I now request Dr. Vesh Kumar Mishra, our Additional Director General, to give the closing remarks. Over to you, sir, please.
Thank you, Bhanumati ji. It has been very good, very useful webinar. Presentations were really enlightening. The basic purpose of the webinar that we had in mind, that to learn from each other and create awareness about the environmental statistics and environmental accounts and the headways that have been made in the direction. That purpose has been, and to me it appears, has been more than fulfilled. And yes, the the presentation from our colleague, our friends from overseas has also been very enlightening, and it was very revealing how the developments in the environment accounts, and they are so helpful in measuring SDG targets against various goals. So it all has been very good. Thank you very much for knitting it this way, and I believe that we have another session tomorrow at the same in the same time slot. So we will learn something more, and all that would be, has been very good. Thank you so much. Over to you, Bhanuti.
Thank you so much, sir. And to all our users who are still online, we do look forward to joining us tomorrow at 11:30. I do hope that the question answer session is of interest to all of you, and you would like all your questions to be answered. So meanwhile, we'll be sending the link for day 2, which is slightly different from today's link. So please be on the lookout, and in case we miss sending you the link, please send us a WhatsApp at 9868213559. I shall be giving the mobile number here, or you could send us an email at ssd-mosby@gov.in. Thank you so much, and meet again tomorrow. Thank you.